Yes, all these basics completed. Yeah, all these basics completed. So last topic, yesterday topic, interpreter and compiler discussed. See Java depends on both yes interpreter as well as compiler. Java depending on both compiler as well as interpreter, right? Yes. So Java, yes, error checking by the compiler, program execution by the interpreter. See, source code to byte code converting by the Java compiler. Java compiler checks for all errors. If no errors, converts into dot plus file. This byte code file. That byte code file converting to binary codes and executing by the Java interpreter. So Java depends on both compiler as well as interpreter. So this thing we have discussed yesterday. Right? Can we create exe file in Java? No. Java don't have the exe file concept. Yes, today we'll discuss about exe file dot plus file. Okay. See, on D1 topics, we have discussed about Java features like just introduction given. Yes, independent of platform. I think day two is a day two topic. Yes, Java features independent of platform, portability, scalability, security, and object-oriented programming. So these just listing given on day two. Yes, today we'll discuss about independent of platform, portability, these features, right? Okay. So let us see about this most important topic. So because of this independent platform portability, Java has this much of popularity. Java popularity main reason is independent platform portability. Okay. Yes, let us see about this. See, Java is an independent. Java independent of Java is an independent of platform. So Java is an independent of platform. Yes, what does it mean here? Java is an independent of platform. What does it mean? Let us see about this. So what does it mean? So this is a question. So let us answer this question. Java is an independent platform. What does it mean here? Java is an independent platform. What does it mean? So first of all, what is platform? So platform means what? What is platform? This platform means see in previous class we have discussed about OS, right? So previous sessions about OS we have discussed. See here in this hardware, there is a hardware. On top of hardware, OS running. On top of OS, all programs running, right? There is a hardware layer. On top of hardware, OS. On top of OS, all programs running, right? Yes, in this here, in this. So these two layers is a platform. So these two layers is a platform, right? So these two layers platform. So on top of it, all the programs running, maybe C program, C++, Java. So this is platform. So on top of it, all are running here. Java, maybe database, Python. Yes, maybe some applications. Yes, maybe Zoom application. Okay. Yes, maybe Word documents, maybe Notepad, and all are running at top of these two layers, right? So these two layers is a platform. So platform means it's a combination of hardware and OS. Platform means it's a combination of hardware and OS. Combination of hardware and OS. Platform means yes, these two layers is a platform. It's a combination of hardware and OS. Hardware and OS. So this is platform, right? So platform means yes, platform means yes, yes, it is a yes, it's a combination. Yes, it's a combination of yes, it's a combination. Yes, it's a combination of hardware, hardware and operating system. Hardware and operating system. Operating system. It's a combination of these two things, right? Yes, it's a combination of these two layers. So here, sorry. So here platform means, see here, yes, today topic, the Java features. Java features, first one, Java is independent platform. Java is an independent platform. What does it mean? Java is an independent platform. What does it mean? What does it mean? Okay, here. So first of all, platform. So platform means. So these two layers is a platform. Okay, hardware layer and OS layer. These two layers is a platform. So in computer, these two layers is a platform. Hardware and OS. So it's a platform. On top of which all are running, right? All are running on top of hardware and OS. So these two layers is a platform. So here platform means it's a combination. Platform means it's a combination of hardware and operating system. Hardware and operating system, right? Okay. Yes. So here Java is independent platform means Java is independent platform means means yes, Java program Java program Java program can run on Java program can run on any any hardware and anyways any hardware and anyways. So Java is an independent platform. Okay, so Java is independent platform means Java program Java program can run on any hardware and anyways. So Java is independent platform means Java program can run on any hardware and anyways. Any hardware anyways. Okay, fine. Yes, now question is here. Question is next question is here. How yes Java made us independent of platform. This is important point. Independent of platform. So how Java made us independent? Yes, independent. Yes, independent of platform. So how Java made us independent of platform? Now we should answer this question. How Java made us independent of platform? We should answer this question. Let us answer this question. Okay. I hope you understand, guys. So today topic is yes, yes, about Java features. Java is independent of platform. Portability, these things. So Java, yes, on day two, I have given list of that features. Yes, Java initial features like independent of platform, portability, and all of these, right? So here, let us see how Java is independent of platform. Let us see about this topic here. Yes. So Java is an independent platform. What does it mean? Here, platform means it's a combination of hardware and operating system. So platform. Here, this is platform here. So platform. So here it's a so here see in your system there is a hardware OS, right? These two layers is a platform. These two layers is a platform. On top of which all are running. All application software like C, C++, maybe some languages, some tools or packages, all are running on top of this platform. Top of this one, right? So these two layers is a platform, hardware and OS. Platform means hardware and OS. So platform. So a platform means it's a combination of hardware and operating system. Hardware and operating system. So Java is an independent platform. Java is independent platform means Java program can run. Java program can run on any hardware and OS. Any hardware and OS. Now question is here, how Java made us independent platform? Okay. Yes, Java program can run any hardware, any OS. Then how? How it is possible? How? So what is reason behind of this? Let us see. So how Java made us independent platform? To answer this question, yes, you must have the exe file and dot class file knowledge. Exe file and dot class file knowledge. Let us see about exe file and dot class file. Okay, so first of all, let us see about exe file in C language. Yesterday we have discussed about exe file, right? Yes, in C language, yes, after compilation, compiler generating exe file, after generating exe file running, right? Let us see about this exe file. Okay, yes. See, first example, suppose C program. I'm taking C program here. Yes, C program exe file. Yes, 1 second. Yes, before that, one question for you guys. One more question for you guys. For example, exe file. Question is exe file prepared. Exe file prepared on Windows OS. On Windows OS. Yes, question is exe file. Question is exe file prepared on Windows OS. Windows OS. Windows OS. Can I run same exe file on Linux OS? This is question. This is question. So question is here. Yes, exe file. Question is here. Exe file prepared on Windows OS. Can I run same exe file Linux OS? Anyone, can you answer this? Simply say yes or no. Okay. Yes, exe file. Exe file prepared on Windows OS. Can I run same exe file Linux OS? Yes. Who is having C knowledge? Can you answer this? Yes, video na. Okay. Let me mute my video. Okay. Okay. Fine. Yes. Ananta Sanja. Answer saying that no. Next, any other answers? Exe file. Exe file prepared in Windows OS. Can I run same exe file Linux base? Yes, for this answer is no. Reason. Yes, for this reason. Yes. So why? Yes, exe file prepared in Windows OS. Can I run on Linux base? Answer is no. No, we can't. 1 second. Let me mute all. Yeah. So answer is no. Reason. Reason. Exe file. Exe file is a exe file is a platform dependent or OS dependent. Exe file is platform dependent. Dependent or OS dependent. Even you can say platform OS anything. So dependent. So exe file is a OS dependent. Reason exe file is OS dependent. Right now, immediately question. Yes, why exe file? Why exe file? Why exe file is OS dependent? Why exe file is OS dependent? OS dependent. Why exe file is OS dependent? Let us answer this question here. So here, so exe file is a platform dependent or OS dependent. Suppose if you preparing exe for Windows OS, it will run on only Windows OS. It will run on only Windows OS. It won't run other operations. Okay, if exe file prepared Windows OS, it will run on only Windows OS. It won't run on other operations. Reason, exe file is a OS dependent. Now question is here, why exe file is OS dependent? That is question. So why exe file is OS dependent? Let us answer this question. To answer this question, yes, you must have the exe file knowledge. You must have the exe file knowledge. To answer that question, you must have the exe file knowledge. Let us see. For example, here, C program exe file prepared on Windows OS. On Windows OS, then yes, it contains what? Then it contains. Then it contains. Then it contains. Then it contains. It it contains what? Let us see. C program exe file prepared and Windows OS. C program exe file prepared and Windows OS. Then it contains what? Let us see. Let us go to C program. Yes, yesterday we had discussed about this one here. Yes, yesterday some partially discussed. So some more topic, more about exe file we'll discuss today. So behind of this, yes, C drive, TC, Turbo C, yes, bin folder here, programs. Yes, this program test.cpp, CPP and C language both are compiler based here. Both are compiler based, so both are exe based. How it's working here? See test.cpp. Bin folder test.cpp, TC, bin, yes, test. Yes, let me delete the testdays, all that here. Test.cpp. Yesterday, 25th 4, right? Just remove this exe file also, this also, just remove this. The test related, all are removed here. Test.cpp. So this is program. Test.cpp, C++. This is also compiler based. See, here I am compiling this program. So first of all, compiling. Success, no errors. Yes, if no errors, see, test.obj file generated. This obj file contains what? Object file. Test.obj object file. So you can, this object file contains binary code for our C program. So this is your C program, right? Your C program. Okay. So void main int a b c. This is your C program. This program completely converting to binary format. C compiler. C compiler converts your code, C program code into binary format and write to obj file, object file. So this object file contains, yes, C program binary code, completely C program binary code, right? Next, here there are predefined libraries, C library, stdio.h, conio.h. So these are predefined library. This predefined library also contains binary codes. This stdio.h header file, conio.h header file, these header files also having some binary code. These header files also binary code, right? Okay. So you can test.obj contains your C program binary code. And next, so stdio.h header files, these header files also having some binary codes, right? Yes. Now, after compilation, next running. So when you try to run it, here, before going to run it, first of all, exe file creates, then running, run. See, exe file, yes, test.exe file created. Here, test.exe file created. Now this exe file contains what? Yes, how this exe file is generating here? How it's generating here? Let us see. Yes, to generate, yes, enter number 10, 20, yes. So addition, subtraction, multiplication done. Okay, right? Now let us see how this exe file generating here. Okay, so for this here, yes, yes, C program exe file prepared in Windows OS, then it contains here, yes, yes, C compiler simply it takes binary code for your C program, the test.obj file, binary code for C program. Yes, C compiler taking binary code for C program, binary code for C program means this is binary code for C program, and then binary code for that C library, binary code for C program, binary code for C library, and also binary code for OS library. Instead of OS, this is a library. Okay, right? By linking with this generating exe file. Okay, a C compiler just is taking binary code for our C program. Binary code for C program means test.obj file, and next binary code for, yes, that C library, stdio.h C library, and binary code for OS library. By linking all of these things generates exe file. By linking all these three, All these three generate exe file finally. Okay, right? So you can C program. So you can, yes, this example, yes, C program exe file prepared on Windows space, then it contains, yes, binary codes, binary, binary codes for C program, binary code for C program plus. Next, binary code for C library, binary code for C library, C library, binary code for C library, binary code for C library, plus binary codes, binary code for binary code for Windows OS library, Windows OS library, Windows OS library. So Windows OS library. Okay, yes. So C program exe file prepared in Windows OS. Then it contains what here? Yes, it contains binary code for C program, binary code for C library, binary code for OS library. By linking all of these things, generates exe file. By linking all these three, generating exe file. That is exactly exe file. Okay, right? Yes, let us take one more example. Let us take one more example. One more example. Let us take one more example. Let us take one more example. Let us take one more example. C program exe. Suppose let us take, yes, C program exe file prepared in Linux base. Another example, Linux base. Okay. Yes, C program exe file prepared in Linux base. Then it contains binary code for C program, binary code for C library, now binary code for Linux based library, Linux based library, Linux based library. Okay, yes, if exe file prepared on Windows base, Windows library linking with the exe file. Yes, if exe file prepared Linux base, then Linux library links to exe file, right? Suppose, let us take one more example. Suppose, yes, C program exe file prepared in Mac OS. Let us take Mac OS. If it is Mac OS, then it contains binary code for C program, binary code for C library, binary code for Mac OS library, Mac OS library, Mac OS library. Okay, suppose one more example, C++. For example, C++. Let us take C++. Yes, C++ program exe file prepared in Windows OS, then it contains, yes, C++ program binary code. Okay, yes, binary code for C++ program, binary code for C++ library. Yes, C++ library and binary code for, yes, Windows OS library. By linking all of this, it generates exe file. Yes, all the cases on all examples, what is common point here? OS library is common, right? All the cases, in all the cases here, OS library linking with exe file. Okay, so what is happening here? So exe file, yes, exe file, yes, always, all the cases, exe file always, okay, yes, always exe file. Here exe file always linking, exe file always linking, linking, exe file, exe file always linking with OS library. Yes, all the cases exe file, yes, linking with OS library, OS library, OS library. Yes, all the cases exe file, exe file always linking with OS library. In all the cases here, exe file linking with OS library. Okay, suppose for example, let us take some test.exe file. Test.exe file. For example, test.exe file prepared. Yes, maybe C program exe file or C++ exe file, .NET exe file, whatever it is, that exe file. Okay, test.exe file. Test.exe file. So for example, test.exe file prepared on Windows base, on Windows base, on Windows base. Test.exe file prepared Windows base. Then, yes, then it links, then it links with, yes, links with Windows OS library, links with Windows OS library, right? Windows OS library, links with Windows OS library. Okay, yes, links with Windows OS library, Windows OS library, right? Yes, test.exe file. For example, test.exe file prepared in Windows base. That test.exe, maybe C program exe file or C++ exe file, .NET exe, whatever it is, that exe file, some exe file. Let us say test.exe file prepared on Windows OS, then it links with Windows OS library. Okay. Now, so test.exe file, test.exe file, test.exe file with Win library, Win library. Yes, working on different platforms. Let us see how it's working on different platforms. Working on different operating systems or platforms. Yes, how it's working here. So working on different platforms, different platforms, different platforms. Yes, if you try to run test.exe file with Win library, test.exe file with Win library, working on different platforms. Yes, how it works on different platforms. Let us see how it works on different platforms. Let us see. So first, let us take Windows platform. Let us take Windows platform. Windows platform. Let us take Windows platform. Yes, suppose it's a hardware. Yes, in our system, there is a hardware, 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 right? Hardware. Here there is a hardware, right? On top of hardware, OS, hardware layer, right? On top of hardware, OS running. So on top of hardware, OS. So this is platform. Let us say Windows OS. So first Windows platform, Windows OS, Windows OS with the Win library. Yes, Windows OS with Win library, right? Now on top of it, now your exe file, test.exe file, not test.exe file. Okay, so you get test.exe file with Win library. So all are linked. So test.exe file all are linked with Windows OS library. So when you try to run test.exe file on Windows OS, what happens here? Yes, this test.exe file it will try to call to Win library. Try to call to Win library. Win library, Win library. So Win library, right? Win library. See, since test.exe file, since test.exe file with Windows OS library, since test.exe file all are linked with Windows OS library, when you running this exe file, when you run this exe file, yes, it will try to call to Windows OS library. Yes, available. Okay, the test.exe file it will try to call to Windows OS library. Yes, it's available. Since available here, simply using that library. So it will try to call to Windows OS library. Yes, it's available. Using that library, it will communicate with the hardware components. So program executing successfully. That exe file executing successfully. Okay, that Windows OS library here is available. So if you're using that library, communicating with hardware components, so program successfully completing. So program successfully executing, right? Now, same exe file. Yes, let us take another platform. Now, Linux platform. Okay, Linux. Let us take Linux platform. So next, Linux, Linux base, Linux, Linux base, Linux base. Okay, so test.exe file, same test.exe file. When you try to run a Linux base, what happens? Linux base with Linux library. See, every base is having its own library. Okay, library is not same. Windows is having its own library. Linux is having its own library. Mac is having its own library. So different operations have its own libraries. Okay, same test.exe file. If you try to run a Linux OS with Linux library, what happens? Same exe file. If you try to run a Linux OS, then what happens here? Yes, now test.exe file. Here test.exe file all are linked with Windows OS library. All are linked with Windows OS. That link is fixed. That link is fixed, never changes. Okay, exe file all are linked with Windows OS library. Yes, since linked with Windows OS library, yes, it will try to call Win library, but here is not available. That environment changed. OS changed. Environment changed. That library changed, right? Okay. Now this exe file test out when you try to execute exe file, it will try to call Windows OS library. It will try to call Windows OS library, but here is not available. That Windows library is not available. Simply it fails. That call fails. It will try to call to Windows OS library, but the library is not available here. Since not a simply call fails, so program execution also fails. Program execution fails. Okay, right? So you can test.exe file linked with Windows OS library. Running on Windows OS clearly here, right? When running on Windows OS is because that library is matching. Since test.exe file is linking with Windows OS library, it will try to call the Windows OS library. It's available already, so it's working right fine. Same exe file, if we try to run a Linux base, it fails. Reason that library is not matching. That exe file linked with the Windows OS library. So the exe file linked with Windows OS library. So at runtime it will try to call Windows library, but here it's not available. That library is not matching. It's not available. Simply call fails. Simply call fails. Call fails here. Yes, program execution also fails. Okay. Now let us take another platform, Mac. Let us take Mac OS. Yes, same exe file. If we try to run on Mac OS, what happens here? So Mac OS with Mac library, Mac OS with Mac library. Okay, now this exe file, test.exe file. So if we try to run the exe file in Mac OS, what happens here? Yes, here also it will try to call Windows OS library. That is library fixed. So once exe file created, that library is fixed. That never changes. It's a fixed. Now again here it will try to call Windows library, but here is not available. That library is not available. Since not available, again fails. Again fails, right? Again fails. Okay. Yes, since test.exe file linked with Windows OS library, it is working on only Windows library. It won't work with other applications. Simply fails. So that's the reason exe file is a platform dependent. Exe file is a platform dependent. So it's a reason. So why exe file is platform dependent here? Yes, why exe file is platform dependent? Reason? Yes, since that exe file, since exe file linked with OS library, OS library statically. So statically means static means fixed. Static means fixed. Okay, that link is fixed. That link never changes. Okay, at the time of creation of exe file itself, at the time of creating exe file itself, linking. So once linked, that never changes. That link never changes. It's a fixed. It means it's statically. That means statically. Yes. Since exe file linked with OS library statically. Yes, it is. It is platform dependent or OS dependent. Yes, it is platform. So platform dependent. Platform dependent. Platform dependent. Platform dependent. Platform dependent. Okay. Yes. Since exe file, yes, linked with OS library statically. Since exe file linked with OS library statically here. Okay. Yes, it's a platform dependent. It's a platform dependent. Okay, right? Yes. Why exe file is platform dependent or OS dependent? Reason that exe file statically. Exe file statically. Yes. Why exe file is OS dependent? Yes, the answer. Since exe file statically linked with OS library, it's a platform dependent or OS dependent. OS dependent. OS dependent. Okay. Yes. Fine. That is about exe file. Okay. So why exe file is OS dependent here? Yes, it contains OS library. That exe file contains OS library and linked statically. So it's a OS dependent. That point is clear. Now come to Java. Yes, how Java made us independent platform? Now this question we have to answer this. This question we have to answer. Now interesting points. Okay. Yeah, this question. How Java made us independent platform? So for this purpose, yes, you must have the dot class file knowledge. About dot. Let us see about dot class file. Now about the dot class file. Yes, about dot class file. Java dot class file. Let us say about Java dot class file. About Java dot class file. About Java dot class file. See, after compilation, in Java is a dot class file. The Java dot class file working, right? Yes, about Java dot class file. Yes, now. Yes, Java program. Now Java program dot class file. Java program dot class file. Java program dot class file. Yes, Java program dot class file prepared on Windows OS. Then it contains what? Then it contains what? Yes, binary code for no, not binary code. It's a byte code. Byte code. Byte code. Yes, after compiling Java program, result is what? Byte code. Dot class file. Yesterday showed that is. Okay. Yes, after compiling Java program, result is byte code. Dot class. Result is dot class. Dot class contains what? Byte code. So bytecode for Java program. Bytecode for Java program. Next, yes, bytecode for Java library. Bytecode. Bytecode for Java library. Bytecode for Java library. Plus, yes, voice. In case of voice library already always in binary format. No bytecode in voice library. Voice library don't have any bytecode. It's a binary code. Always binary code only. Voice library always binary code only. Binaries, voice binaries. Voice binaries. Okay. Now in this here, Java program dot class for prepared ingress voice, then it contains bytecode for Java program, bytecode for Java library. That's it. It won't link with voice library. It won't link with voice library. Okay, it won't. Yes, it won't link with voice library. So dot class file contains bytecode for Java program, bytecode for Java library. See, Java library also developed in Java. Java library also developed in Java. See, here C language. C language library developed in C language only. C++ library in C++ only here. Python library in Python only here. Right? Okay, now Java library also developed in Java here, right? Okay. So here, so dot class file contains bytecode for Java program, bytecode for Java library. So Java library also in Java. Java library also in Java. That means dot class file is a pure Java program in bytecode format. So you get dot class file. So dot class file is a pure, yes, is a pure, yes, is a pure, yes. So dot class file is a pure Java program, pure, pure Java program, pure Java program in bytecode format, in bytecode format, in bytecode format, in bytecode format, in bytecode format. Okay, so you get dot class file. So dot class file is a pure Java program in bytecode format. Here dot class file. So dot class file. So Java dot class file. So what is dot class file? Now dot class file is a pure Java program bytecode format. Okay. Yes, it don't have any voice library. Yes, it don't have any voice library. It don't have any voice library. It don't have any voice library. Okay. Yes, it is free from voice library. It is free from, yes, it is free from voice library. It is free from voice library. It is free from voice library. Okay, right? Yes. So dot class file is a dot class file is a pure Java program in bytecode format. In bytecode format, it don't have any voice library. Okay. Yes, it is free from voice library. So dot class file don't have any voice library. Dot class file don't have any voice library. Fine. Now let us take some example here. How Java dot class file is working. Suppose let us say tested dot class file. For example, tested dot class file. Yes, take, yes, tested dot class file. Suppose tested dot class file prepared. Yes, tested dot class file. Yes, yes, maybe prepared. One second. Suppose tested dot class file. Yes, might be prepared. Prepared on anyways. Anyways. Okay, don't have any ways library. Okay, tested dot class file. Okay, tested dot class file might be prepared anyways, but don't have any ways library. But don't have, yes, don't have any ways library. Don't have any ways library. Anyways library. Yes, the tested dot class file might be prepared anyways here. Don't have any ways library, right? Not tested dot class file without any ways library. It's a free from ways library. Now, how it's working on different platforms here? Not tested.class. This tested.class file is working on different platforms. So working on different platforms. Working on different platforms. So working on different platforms. Working on different platforms. Tested.class file working on different platforms. Yes, let us take. So first Windows platform. How tested.class file working on Windows platform? So working on different platforms. So first Windows platform. Tested.class file. Okay, tested.class file, right? Tested.class file. Tested.class file don't have any voice library, right? So you can now this tested.class file running in this base. Not tested.class file don't have any voice library, right? Now can I run this tested.class direct in this base? No, no. because this dot class file has to communicate with hardware, right? A dot class file has to communicate with hardware. Yes, in order to communicate with hardware, this dot class file it has to link with Windows OS library, otherwise cannot communicate. But don't have link. Yes, this dot class file don't have any link. So dot class file free from OS library, it don't have link with any library. Yes, the test dot class file don't have link with any OS library. It don't have any OS library, but it has to link. Yes, to run test dot class file, it has to link with Windows OS library. Okay, if it is linking with Windows OS library, then it can communicate hardware, right? Okay, not only Java program, every dot class file, yes, not only Java program, every program. See, previously we had discussed one point here. See, every program has to link with OS library before going to run it here. Yes, maybe C program, Java program, maybe Python, so maybe database or MS Office, everything, whatever running here, applications office. All these programs, first of all, linking with OS library, half linking with OS library, then communicating with the hardware. Communicating with the hardware, right? Suppose if it is C program, exe file, if it is C program, at the time of creation of exe file itself, okay, in C line, in C programming, at the time of creation of exe file itself, static linking. At the time of creation of exe file itself, linking then working, right? All a link is there, working. But dot class file don't have a link here. Then how it work here? No, it won't run directly here. It won't run directly. Now this test.class file, this test.class file has to link with Windows OS library. Okay, every program has to link with OS library, otherwise cannot run. Now this test.class file also has to link with Windows OS library. Yes, who will link it here? So who will link it here? Yes, to link test.class file with Windows OS library. So to link test.class with Windows OS library here, one more layer will come to picture. So between these two layers, one more layer will come to picture. So what is this layer? So one more will come to picture. Yes. Anyone can you guess it? Yes. So this tested dot class file linking with Windows OS library. Yes, to link. Yes, to link tested dot class file with Windows OS library. Yes, something will come to picture. Anyone can you guess it? Anyone can you guess it?
Interpreter, sir.
Yes, Srikanth saying something?
Interpreter?
No, not interpreter.
No.
Yes, of course, interpreter, okay. Yes, yeah, partially right. Yes, exactly what. Yes, anyone can guess it. Yes, no, JVM will come to picture. Inside of JVM, this interpreter. That interpreter working for linking. Okay, in JVM, I'll explain about interpreter. Now JVM will come to picture. Okay, now get JVM. So JVM simply is taking test.class file and linking with Windows OS library. So once linked here, then it communicates with the hardware, then executing successfully. So see this on Windows OS, this is JVM, Windows JVM. On Windows OS, there is JVM, Windows JVM. Now Windows JVM taking test.class file linking with Windows OS library. So once linked, successfully execution. Once linked, successfully execution. Okay. Now let us take another platform, Linux platform. Yes, if it is Linux platform. Yes, Linux platform. If it is Linux platform, Linux base, Linux base with Linux library, Linux base with Linux library, Linux base with Linux library. Okay. Yes, if it's Linux platform here, that Linux base contains Linux base library, Linux library. Now that case, so what happens here also same window, same yes JVM. So this Linux base contains JVM. See, Windows JVM contains Windows JVM. So Windows, yes, if test.class for running on Windows OS, Windows JVM taking test.class for link with Windows OS library, half linking then executing. Same test.class for if you're running a Linux base. Now Linux JVM come to picture. Now Linux JVM taking test.class file links with Linux OS library. So once linked here, then executes running successfully. Same exe, same dot class file. If you're running on Mac OS, now Mac JVM come to picture. So every OS has its own JVM. Now Mac OS with Mac library, Mac OS with Mac library. Now Mac JVM will come to picture. So Mac JVM. Now Mac JVM. So Mac JVM taking test.class file links with Mac library. So once linked with Mac OS library, then executes successfully finishing. That's it. Now here JVM is responsible. JVM. Yes, in Java, JVM is responsible to make the dot class file as independent of platform. Now what is happening here? Every time of changing ways, that link is changing, right? That library is changing here, link is changing. So if it is running on Windows OS, links with Windows OS library. Yes, same dot class file. If it is running on Linux OS, links to Linux library. Same dot class file. If it is running on Mac OS, links to Mac library. Right? So that library changing at runtime, library changing. That is, yes, it's a, yeah, that concept is dynamical linking. Dynamically. Okay, dynamical, right? Every time of changing ways, that library changes, that link changes. It is called as dynamical linking. Okay, yes. Since Java dot cluster, since yes, since dot class file, yes, since dot class file, since dot class file, dynamically, dynamically, dynamically linking. Yes, dynamically linking with OS library, by the JVM, by the JVM, by the JVM. Yes, it is a platform independent. It's a platform dependent. It's a platform. It's a platform independent. It's a platform independent. Right? It's a platform independent. Okay. Yes, the platform independent. Yes, since dot class file. Okay. Yes, since dot class file. Since dot class file dynamical linking. Since dot class file dynamical linking with OS library by the JVM. It's a independent of platform. Here JVM. Yes, JVM makes the dot class file as independent of platform. So every time of changing ways, that link changes. Every time of changing ways, that link changes, right? It's a dynamic linking. Yes, in C programming exe file, what happens? Maybe C programming exe file, C plus exe file dot and if it is exe file, that link is fixed, never changes. That link is fixed. Yes, if it is linked with Windows OS library, always only Windows OS. It won't work with other operations because that link is fixed. Statical linking. That link is fixed, called as statical linking. Exe file always statical linking with OS library. Since exe file, since exe file, yes, since exe file, statical linking. Okay, since exe file linked with OS library is a platform dependent. Since exe file statically, yes, let me change this. Yes, yes, since exe file statically, yes, statically linking with OS library. OS library is a, yes, it's a platform dependent or OS dependent. Okay, right? Yes, since exe file statically linking with OS library is a platform dependent. Yes, when come to dot class file, here dot class file dynamic linking. Every time of changing ways, that link changes. Every time of changing ways, that link changes. Now, which is responsible here? JVM. JVM is responsible. Okay, since dot class file dynamic linking with OS library by the JVM, yes, is a platform independent. So this is reason how Java made us independent of platform. So how Java made us independent of platform? Yes, how it is independent of platform? Yes, how Java made us independent of platform? Answer is this. Yes, since dot class file dynamically linking with OS library by the JVM, it's an independent of platform. So not only Java, yes, not only anywhere, any language which is statical linking, that is platform dependent. Dynamic linking is independent of platform. Okay, so statical linking. So wherever statical linking, so you can generally exe file is statical linking. Yes, statical, simple here. Static, if it is statically linking, statical linking. Statical linking. If it is statical linking. So this is platform dependent, platform dependent. So dynamical linking. Yes, if it is dynamically linking, dynamical linking. So dynamical linking. So dynamical linking. So this is independent of platform. Independent. Yes, independent of platform. Independent of platform. Independent of platform, right? Independent of platform. Because statical linking, yes, platform dependent here. Dynamic linking, independent of platform. Independent of platform, right? Yes. See, not only Java, even Python also. See, Java and Python. Java and Python. So Java and Python programs. Java and Python programs dynamically, dynamically linking with OS library. Dynamic linking with OS library. So dynamic linking with OS library. Yes, since dynamic linking, these both are independent of platforms. Yes, both are independent of platforms. Even Python are independent of platform. Both are independent. Independent of platform. Yes, independent of platform. Independent of platform. Yes, even Python are independent of platform. Java and Python both are independent of platform. Python and Java both are independent of platform. Reason? Yes, reason Java and Python programs. Yes, dynamically linking with OS library. Both are dynamically linking. So since dynamically linking with OS library, those are platform independent. Platform independent. I think yes. I think yes. Now you get doubt too. Yes, definitely getting everyone getting doubt too. See, if dot class file running in Windows OS, Windows JVM, Windows JVM test taking test dot class file linked with Windows OS library. Same dot class file if it's running a Linux OS, Linux JVM linking test dot class file with Linux OS library. If it is running on Mac OS, Mac JVM. That means every OS has its own JVM. Every OS has its own JVM. Now question is here, JVM is it part of OS? That is question. Okay. JVM, is it part of OS here? No. JVM is not a part of OS. JVM, yes, JVM is not a, yes, JVM is not a part of OS. Is not a part of OS. No, it's not a part of it. JVM is not a part of OS. Then from where getting JVM here? How can you get JVM here? JDK. Yes, it's a part of JDK. It's a part of JDK. It's a part of JDK. It's a part of JVM. JDK. Yes, JVM. See, JVM is not part of OS. JVM is not a part of us. It is from JDK. Yes, it is from JDK. JVM is from JDK. JVM is from JDK. Right? It is from JDK. Okay. So JVM is not a part of operating system. Yes, it is from JDK. Yes, once JDK installed, it's getting JVM. Yes, to get the JVM. How can you get JVM? To get JVM. Yes, to get JVM. Yes, we should install. So we should install JDK on your OS, right? Yes, we should install JDK on operating system. So once JDK install, we can get JVM. Okay. Yes, to get JVM. So to get JVM, yes, we should install JDK on OS. So once JDK installed on OS, getting JVM. Yes, that JVM is responsible to make the dot cluster independent platform, right? Yes, to get JVM, we have to install. We should install JDK and OS. So once JDK installed, we can get JVM. Now that JVM is responsible to make dot cluster independent platform. Next, one more interesting point here. One more interesting point. See, dot class file is an independent platform. Independent platform. Dot class file is an independent platform. But JV is a platform dependent. JV is a platform or OS dependent. Platform dependent. Platform dependent. See, so dot class file is independent platform. Okay. Dot class file. Interesting point here. See, dot class file is a platform. Yes, independent but JV is a platform dependent. JVM is a platform dependent. Okay, here Sun Microsystems. Initially, Sun Microsystems, Sun Microsystems have developed. Yes, Sun Microsystems they have developed. Yes. JVM, JVMs for, yes, JVMs for different operations in the market here. Okay. Yes. Initially, Sun Microsystems have developed JVMs for different operating systems. Okay. Yes. Right. Like for Windows based Windows JVM they have developed. For Linux based Linux JVM. For Unix based Unix JVM. For Mac based Mac JVM. For every base they have developed here. Sun Microsystems they have taken risk to make the Java as independent platform. For every base separate JVM they have developed. Okay. Yes, Sun Microsystems have developed JVMs for different operations. Okay. Yes. JVM for Windows base, JVM for Windows base. Yes, JVM for Linux base, JVM for Mac base. See, Windows base, Windows JVM is having knowledge of Windows base so that it can link it to Windows base library. Next, Linux JVM is having knowledge of Linux base library, so linking with Linux library. Next, so Mac JVM is having knowledge of Mac library, linking with the Mac library. Like that, they have developed JVM here. So every ways there is a separate JVM they have developed here. For every way, separate JVM developed here. Okay, so Windows JVM is having knowledge of Windows base, then linking with Windows base library. Okay, right? Next, Linux JVM. Linux JVM is having knowledge of Linux library, links with Linux library here. So Mac JVM is having knowledge of Mac base, the links with Mac library. Right? Okay. So it's for every base, separate JVM was developed here. For every base, separate JVM was developed. Next, one more interesting point here. See JVM, yes, JVM developed. See JVM developed in C++. Okay, JVM developed in C++. Behind of JVM, C++ code will run. Okay, so when you're running Java program, so behind of Java program, JVM running. The JVM running inside the C++. C++ code will run. C++ code will run, right? C++ code will run here. So JVM developed in C++. Okay, that means yes, here JVM is a C++ exe file. Actually, JVM is a C++ exe file. So JVM is a C++ exe file. Right? Yes, if it is exe file, for every base that exe file changing. Okay, yes, C++ exe file, since exe file for every base separate JVM. That exe is not same, right? Exe is platform dependent. Exe is voice dependent. Okay, so JVM is a voice dependent because a C++ exe file. Okay, so Windows, yes, Windows JVM. So Windows JVM is a Windows, yes, Windows JVM is a, yes, Windows based C++ exe file. Linux JVM is a Linux based exe file. Yes, next Mac JVM is a Mac based exe file, right? Okay, so JVM developed in C++. It's a C++ exe file. Since exe file is a OS dependent. OS dependent, right? OS dependent. OS dependent. Okay, yes. So a Java program is a dot class file is a independent platform, but JV is a platform dependent. JV is a platform dependent. Reason it's exe file. JV is exe file. So JVM is exe file. Okay, for every ways separate JVM they have developed here. So Windows based JVM, Windows based exe file. Okay, for Linux based JVM exe file. Yes, if it is Mac based exe file. That's it. I hope understand, right? Now question is here. Suppose JDK for Windows base. Suppose JDK, for example. So this is JDK, right? JDK for Windows base. Same JDK can I install on Linux base? Yes, same JDK can I install on Linux base? So let us see about this. Let us see this. Someone trying to say answer. Windows
No,
JDK
sir.
can I install Linux base? No, no. Reason here. Yes. So instead of JDK, there is a JVM, right? Inside of JDK, there is a JVM. Inside the JDK, there is a JVM, right? Okay. Yes. If it is Windows base, the JDK should contain Windows JVM. Okay. Yeah, JDK for Windows. JDK for Windows. must have JDK for Windows, must have, yes, Windows JVM, right? Windows JVM. Windows JVM, right? Yes, JDK for Windows base must have Windows JVM. Yes, suppose JDK for Linux base. Yes, JDK for Linux base must have Linux JVM. Linux JVM, right? Linux JVM. Yes, JDK for, yes, JDK for Mac base, Mac base must have Mac JVM, right? Yes, since JVM changing, JDK also changes. Okay. Yes, Windows JDK contains Windows JVM, Linux JVM, Linux JDK contains Linux JVM here. Yes, JDK for Mac contains what? Mac JVM. So that JVM changing, right? Since JVM changing, JDK also changes. JDK content will change here. JDK for Windows, that should contain Windows JVM. JDK for Linux, yes, that must have Linux JVM. JDK for Mac OS must have Mac JVM. Okay, that means so JDK is not same here. For different platform, different JDK is in here. Yes, if we downloading JDK for Windows OS, that is working for only Windows OS. Windows OS. Let me show that. Let me show that JDK. JDK downloads. See downloads. JDK downloads. JDK suppose 1.8. JDK 1.8. JDK was see Oracle Corporation. So Oracle sites. See here. This is. So this is JDK downloads. JDK downloads, right? JDK downloads. Okay. See for Linux. So this all is Linux JDK. Linux stage. Yes, in Linux also we have different flavors. Different flavors of Linux base. Different flavors like Ubuntu, yes, Ubuntu base, CentOS, Kali Linux. Okay, like that we have different Linux flavors. So depends on Linux flavor. Yes, that JDK changes. Okay, like Ubuntu Linux, CentOS, and Red Hat Linux, like that. For example, here RPM, Red Hat Pack Manager, RPM. This RPM file is using for Red Hat Linux. tar.gz. This is for, yeah, this is for Ubuntu Linux base. So it depends on that Linux base. Again changes here. See Mac with a .dmg file. .dmg. So this is Mac JDK. Next Solaris base. Solaris also from the Sun Microsystems. Okay, Solaris and Java both are from the Sun Microsystems. Okay, that Sun Microsystems now it is Oracle Corporation. So even Solaris base also with Oracle Corporation. So Oracle Corporation, right? So Solaris JDK for Solaris base. Next JDK for Windows base. Yes, you guys JDK for, yes. Now which one you have to download it here? Last one, Windows 64-bit. Yes, Windows X64, Windows 64-bit base. This one you have to download it. Windows 10, 11. Okay. Yes, Windows 10 and 11. So for these things here, we should use this one, last one. Yes, you guys, not necessary to download it here. I'll share that. Yes, our office software, I'll share it. You don't worry. Okay, so what are the softwares we are using? Same software I'll share through the Google Drive. Okay, I think yesterday, yes, yesterday for most of the students given access. Yes, most of students already paid. Out of 14, I think 12 students paid already. For yesterday, 12 students access given. Yes, go to your Google, go to your Gmail and check it. Just open your Gmail, check it here. If not getting, today may be getting. Okay. Yes, whoever paid yesterday before 12 o'clock, I have given access. Okay, I think maybe somebody paid in the evening, for them may not be getting access here. Today, getting access. Okay. Yes, 12 students have paid for them. Yes, already access given. Already access given. Okay. Yes. So you guys don't worry in downloading here. Don't worry in downloading. I'll provide that. In Drive, it's available. In Drive, it's available. I'll provide the access. Okay. So you get this. So JDK is not same for all operations. Different. Depends on ways that JDK changes. Depends on ways that JDK changes, right? Yes, this is, yes, exe file dot class file. Yes. So you can wherever static linking, that is platform dependent. So dynamic linking independent of platform. Okay. Now finally conclusion. So why exe file is platform dependent? So why exe file is platform dependent? Why exe file is platform OS dependent? Reason, since exe file statically linking with OS library, statically linking with OS library, that is OS dependent. Okay, right? Yes. So why? Yes, this is how Java made us independent of platform. Reason, since dot class for dynamic linking with OS library is a platform independent. So static linking, dynamic linking. I think clear, right? Now, so what's the difference between exfl dot class file? Let us come to conclusion here. Yes, exfl dot class file differences. Let me explain. Exfl dot class file differences. Yes, exfl dot class file differences. Yes, exfl dot class. So exfl on a dot class file. Exfl on dot class file differences. Yes, the first point, exfl. See, exfl is a first difference is binary code file. Yes, is a by exe file it's a binary code file. First difference, first of all, it's a binary code file. It's a binary code file. What is dot class file? Yes, it is a byte code file. It's a byte code file. Yes, it's a byte code file. It's a byte code file. Yes, exe file is a binary code file. Yes, it's a byte code file. Yes, binary code. Binary code. It's a system understandable language. Yes, it is a processor. It's a processor means your system. Processor understandable language. Processor understandable is computer understandable language. Computer can understand it, right? Computer understandable language. Bytecode is a JVM understandable language. It's a JVM understandable language. Okay, JVM understandable language. See, actually here inside the JVM this is a Java interpreter. Inside the JVM this is Java interpreter. The Java interpreter taking this bytecode file, converting into binary codes. After converting into binary code, links with OS library. Yes, in JVM, I'll show that practically. In JVM, we'll discuss. Wait. So wait for 2 more days about JVM. Okay. Yes, after finishing yes, Java installation, next after writing first program, you can understand JVM clearly. You can understand JVM clearly. So JVM may be Monday topic. About JVM, I'll explain Monday topic. Tomorrow we are going for all the setups. Java installation, Eclipse installation. Tomorrow Saturday. Saturday, yes, going for all the setups here. So Sunday you can place that time here. Saturday I'll explain all the setups. That setups you can do on Sunday. So 1 day gap getting that gap you can utilize for the Java setup and Eclipse and all that here. Okay, fine. Yes. So JVM. Yes. So dot class file is a JVM understandable language. Right? Next here, exe file. So you can exe file. So exe file contains what here? Exe file contains OS library. Exe file contains OS library. Yes, here dot class file. Dot class file don't have OS library. So dot class file don't have OS library. So here exe file. See, main difference between exe file dot class file. Main difference is here is a OS library. That difference here. So because of OS library only independent of platform Java. Yes. So because of exe file contains OS library, it's platform dependent. Exe file contains OS library. Dot class file don't have any OS library. Any OS library, right? Next exe file statically, yes, linking with OS library. Exe file statically linking with OS library. Exe file statically linking with OS library. Yes, dot class file. So dot class file dynamically linking, dynamically, dynamically linking, dynamically linking with OS library. So dynamically linking with OS library. OS library. So OS library. So exe file statically linking with OS library. Dot class file dynamically linking with OS library. Right. So exe file dot class file. So exe binary code dot class byte code. Exe is a system understandable language. Yes. So JVM. Yes, dot class JVM understandable language. Exe file OS library contains here. Yes, dot class for don't have OS library. So exe file statically linking with OS library. dot plus for dynamically linking to OS library. Next exe file. Yes, exe file is a platform dependent. Yes, next difference, exe file is a platform dependent. So platform, yes, platform dependent. That platform dependent. Yes. So dot plus. Yes, it's a independent of platform. Yes, it's independent. It's an independent of platform. Independent of platform. Right? Independent of platform. Next, one more difference here. Yes. See, very interesting point. Suppose this is a Windows OS. For example, Windows OS. So here, C software installed. For example, C software installed. C software installed and developed. Okay, C program. Okay, and finally generated exe file. Generated exe file. After generating exe file, that the exe file, yes, successful execution. Yes, same exe file. Now same exe file moving onto another Windows OS, another computer with same Windows OS, Yes, can I run? Yes, to run because same Windows is same, way same, right? Yes, same exe file moving onto another computer with same OS, same OS. Now, can I run exe file without C software? That is question actually here. Okay, same exe file moving onto another computer with same interface. Yes, now can I run? Yes, can I run exe file without C software? Yes, we can run it. Yes, is this software required or not? Okay, see, I'm repeating point once again. Suppose C software installed and developed C program generate exe file on Windows OS. See, on Windows OS, C software installed. So next, developed C program exe file created. Same that exe file moving on to another computer with same Windows OS. We can run it. Yes, we can run it. That exe can run because way is same ways. Exe can run, but without C software. Without C software, can I run it here? Can I run? Yes, can I? Yes, can I run exe file? Can I run? Can I run? Yes, exe file without C software. Yes, anyone can you guess it? Yes, without installing C software, can I run it or not? Yes, we can run. C software is not necessary. Once exe file created, once exe file generated, that exe file contains everything. That exe file contains C program code, C library, and OS library. Everything is a prepared file. Yes, exe file is a prepared file. See exe file. Yes, exe file is a yes, exe file is a prepared file. Prepared file for specific ways. For specific ways. For specific ways, is exe file is a prepared file for specific ways. If it is prepared for Windows base, yes, always running on Windows base without installing C software. Okay, so C software is not necessary. C software is not necessary, right? Yes, to run exe file, yes, that application software. Yes, application software, maybe C software or C++ software. Okay, .NET software, those are called application softwares. Application software, yes, application software. Yes, application software is not necessary. So is not necessary because it's a already prepared file. Okay, yes, exe file is a prepared file for specific OS. Exe file is a prepared file for specific OS. Since already prepared for the specific OS here, yes, to run exe file, application software is not necessary. Okay, if it's running a same Windows OS, yes, not necessary. Already prepared for Windows OS is a prepared file, so that is not necessary. Application software is not necessary. Now come to Java. Suppose Java dot class file. Okay, suppose dot class file prepared in Windows OS. Dot class file prepared in Windows OS. Now same dot class file moving at another computer, same Windows OS. Can I run it directly without Java software? Can I run dot class file without Java software? Can I run? Can you guess it? Yes, it's very simple to guess it. Can I run? Can I run Java dot class file without Java software? Yes, to run the dot class file, what is requirements? JVM required. To run dot class file, compulsory JVM required. Without JVM, we cannot run dot class file. To run the dot class file, compulsory JVM required. How can you get JVM? You have to install JDK. So once JDK installed, getting JVM. After getting JVM, you can run the dot class file. So to run the dot class file, compulsory, yes, Java required. Compulsory Java required. Otherwise, you cannot run it. Okay, to run the dot class file, compulsory JDK you have to install. Without installing JDK, you cannot run it here. You cannot run it, right? Yes. So here, yes, dot class file. See, dot class file. See here, dot class file is not a prepared file. Dot class is not a prepared file. So dot class is not a prepared file. Dot class is not a prepared. It is not linked with any ways. Dot class is not a prepared. It's not linked with in any ways, right? It has to link with runtime here. Dot class is not a prepared file. It has to prepare at runtime. Dot class file should be prepared at runtime as per the ways, right? Okay. Yes. So here, yes, yes. Since dot class file, see, since dot class file, yes, dot class file, yes, is not a prepared file. Is not a, yes, is not a prepared file. Prepared file. Prepared file. Yes. Yes. To run dot class file, JDK required. Java software has to install it. Java software. Java software should be installed. Java software should be installed. Should be installed. Otherwise, cannot. Java software required. So once Java software installed, getting JVM. That JVM, yes, will prepare the dot class file. The JVM will link dot class file with Windows based library or Linux based library or Mac based library. Yes, C program is a already prepared file. Exe file is a prepared file for specific ways. Since prepared file to run exe file, application software is not necessary. But dot class is not a prepared file. Since dot class is not a prepared file, to run dot class file, Java software should be installed. Java software should be installed. Right? That's okay, fine. Next, now which is running fast? Exe file and dot class file. Exe file and dot class, which is running fast? Yes, exe file running fast because already prepared file. Okay, yes. So since exe file, since exe file prepared, already prepared file, already prepared file, already prepared file. Yes, it will run fast. Yes, it will run fast, right? Fast. Yes, in case of Java, what happens? Dot class file preparing at runtime. At runtime itself preparing. So JVM taking dot class file. Yes, JVM takes dot class file. Yes, it converts bytecode to binary code, then linking. So bytecode to binary code conversion, linking to ways this happens at runtime. Means preparing at runtime here. Inside of JVM, there is a Java interpreter. Inside the JVM, there is a Java interpreter. That interpreter taking your dot class file bytecode, converting it to binary code, that linking with ways library. Okay. Inside the JVM, there is a interpreter. 1 second, just a minute. Yes, JVM topic. Monday getting JVM topic. After installing Java tomorrow, yes, we'll discuss first program. On Monday, I will explain JVM. Yes, once first program completed, you can understand JVM topic clearly. 1 second. Inside of JVM, this is all this installation topic. Yes, first program, about first program. Now here JVM. JVM here. JVM, see. Instead of this is whole thing is JVM. Yes, instead of JVM class loader, there are many components. Here there is an interpreter. This interpreter. Yes, instead of JVM Java interpreter, that interpreter taking dot class file and converting into byte code, converting to binary code. After converting to binary code, linking with Waste library. So this interpreter taking dot class file, that byte code converting into binary format and linking with Waste library. That happens at runtime. So preparing at runtime. So Java programming preparing at run. Since Java programming preparing at runtime, it will take some time to run it. So running slowly compared to exe file, dot transfer running slowly, not much slow here, somewhat yes slow. Okay, since dot class file prepared, since dot class file prepared at runtime, runtime by the JVM, runtime by the JVM. Yes, it will take yes, it will run slowly, slowly, slowly compared to exe file, some little bit slow, not much slow here. So it will run slowly here. Yes, it will run compared to exe file, some slow. Okay. Yes, since dot class are prepared at runtime by the JVM, it will run slowly than exe file, slowly than exe file. That's it. Slowly than exe file. Okay, right? Yes, even to improve the performance of Java program, there is JIT added. This topic next list. JIT compiler added. JIT added. So because of JIT, Java program running fast. To make the Java program fast, JIT added. Later versions added. That is, we'll discuss. Wait. Okay, right? So this is about exe file dot class file defenses. So how Java made us independent of platform? Okay, topic is very clear, right? Yes, why exe file is platform dependent? Exe file is platform dependent. Dot class is independent of platform. That difference is very clear. Okay, same this topic. Yes, I have prepared in document here. Let me show the document also. Same topic in document.
In dot class file what contains and bytecode and what contains.
Yeah, what is exactly bytecode? I'll tell you. So once Java programming started, I'll show the bytecode. Okay. Yes. First program. Once first program finished, I'll show the bytecode. So this is a difference between exe file dot class file. Yes, all that. Yes, all the 8 points. Whatever explained here, all these 8 points I have prepared here. All the 8 points. So this is exe file dot class file differences. Okay. Once again, same topic. Just you try to search on Google. Yes. How Java made us independent of platform? Yes, Google won't give this much of information. Okay. Difference between exe file dot class file. Just search it. Even you can't get this much of information. Okay. Not only Google. No Java trainer will explain this concept. I'm sure it's my challenge also. No Java trainer will explain this kind of concepts here. Exe file, dot class file. Yes, internals of exe file. No one knows about it. Yes, if you Java developer, even having 20 years of experience Java, they don't know about that exe file concept. Okay, even Java trainers, they don't know about it. Then maybe question how I got this knowledge here. Because for my first 4 years of experience, embedded C. My first 4 years I worked at embedded C, later started Java. Okay, 97, 98, 99, yes, 2000 beginning, yes, embedded C I worked. 2000 end, yes, shifted to Java career. Because that time Java is very hot. Okay, so that's the reason I have moved to yes Java. At that time, yes, I taken right decision. Because of that decision, yes, cool, happy life. So 25 years of experience in Java here. So without any changing technology here, working Java. Just we are upgrading, that's it here. Just upgrading technology, that's it here. Okay. Right. So because of this reason, I have this much of knowledge. Okay. My knowledge is different from others. Okay. I have multiple skills. Embedded C language, next Linux based knowledge, next Java experience, big data experience, Hadoop experience. Okay, even VC++ experience or databases experience. I have many skills because of 20 years of experience. Suppose you guys are worked for more than 20 years, we'll get that much of experience. Multiple skills. So because of multiple skills, yes. So I have this much of knowledge here. Not a knowledge, even I have the delivery skills also. Yes, presentation skills, good presentation skills, and good communication skills. Good presentation, good communication, and excellent knowledge in technical care. Because of that, I'm able to deliver all of these things, right? Yes, till end of the batch, same interest you will see. Okay, generally here, most of the trainers said the beginning classes very interested. Going forward, losing interest. Okay, we get the topics will be like this. But my topics are just going day by day interest increasing. Every day interest increases. Yes, improving your coding skills. Main focus on coding skills. How to develop your coding skills, how to build your logics and all that. Yes, 100% I'll make you expert in coding skills. Okay. Yes, no doubt. Yes, 100% assurance from my side. Okay. 100% will get the coding skills, good coding skills and getting success in Java. Okay. See, most of the trainers simply they says that Java is tough. No, the Java is not a tough. Java is very simple and easy. Even students also feels that Java is tough. No, Java is not a tough. Java is very simple and very easy. I'll make it easy. That depends on trainer and depends on faculty and all that, right? So faculty explaining easily, then students also becomes easy here. Okay, right? Yes. So you guys don't worry. I'll explain like a spoon feeding every topic clearly, each and every point. I'll explain very clearly. I'll make it easy. Java is very simple and easy to understand. See, if you're good at core Java, yes, rest of the things nothing here. Like frameworks, very simple. Advanced are simple. Spring Boot, and microservices are very simple and easy to understand. Only, yes, you should be good at core Java. If you're good at core Java, frameworks are nothing. In frameworks, you are not going to write any code. Already predefined service available. You have to use that. That's it here. Yes, to use predefined services, we have to write some little bit some code. That code is core Java code. Yes, if you're able to write code Java code, then frameworks application development is very simple. Okay, just you should be good at core Java. If you're good at core Java, Java is very simple, right? Yeah, so that's all for today. Any doubts, guys? Yeah, Srikanth, yes, let me check it. I'll check it. Yes, you paid but
Sure,
did
sir.
not receive access. Okay, I'll check it. Let me check it. I'll check with
Thank you,
online
sir.
team. I'll give the access definitely. So
Sure,
whoever
sir.
paid for everything, everyone today getting access. Okay, tomorrow topic is Java installation. Tomorrow, yes, you have to download Java software from your Google Drive. Today I'll give the access. So who got the access? So tomorrow you have to download it. That you have to download it. You just download it and install in your system. So tomorrow we'll see how to download JDK from your Google Drive. Okay, next how to install. Next how to set up Eclipse and all that. I'll explain clearly. Tomorrow we are going for installations. Tomorrow going for installations. Yes, Krunal, can I join evening batch simultaneously? Evening batch, yes, I think already some 15 to 16 classes available. Sorry, 15 to 16 classes completed. Yes, you can join, no issue. Yes, still whoops not started. Evening batch, still whoops not started. So parallel you can come to that batch also. Okay, parallel you can come to that batch as no issue. So here now morning beginning classes, evening batch. Yes, I think some loops going on. I'm explaining loops, programming skills, coding skills going on. In evening batch, coding skills going on. Yes, maybe after 1 week getting loops. Okay. So still whoops not started. You can join with that batch. Yes. Kunal, is it okay? Yes. Yeah, yeah. Just okay. So after paying fee, just you can contact me. Just I can give the evening link also. So parallel both you can attend, no issue. Okay, right? Yes. Any doubts, guys? Any doubts? No doubts, right? Yes, no doubts, right? Yeah. 1 second.